Hi, hello, welcome to another exciting math lesson. Today we're going to talk about theorems of parallelograms. Let's get started. So during this lesson, you're going to learn how to understand how theorems of parallelograms work, and then be able to tell the difference between squares, parallelograms, and rectangles. Here we go. So quickly, a parallelogram is a four-sided polygon in which opposite sides are parallel and equal in length. So that's an important part. They're parallel and equal in length. And opposite angles are equal in measure. Okay, diagonals is a line within a quadrilateral that connects two corners that are not consecutive. Consecutive angles are two angles in a row when following the perimeter of a polygon. So the key here is in a row. Opposite angles are non-consecutive angles, so they're going to be across from each other. Bisect means to cut or split into two equal parts. All right. So here's a parallelogram. We know that the opposite sides are congruent. Okay. Also, we know that the opposite angles are congruent, so that's where these lines come in. Okay, and we know that the diagonals bisect each other. So what that means is if I take a diagonal here and a diagonal here, it will cut this into equal parts, which is kind of cool. Okay. All right, so we're going to do a proof here. Opposite sides, so we want to prove that the opposite sides of parallelograms, or the parallelogram to the right, are congruent. So what we're going to do is, first of all, I'm going to bisect these angles right there, okay? And then also bisect that, okay? What that does is that tells me that this side, or that length is equal to that, this one's equal to that, that segment is equal to this segment, okay? Well, now what we can do is we can kind of use some of the stuff we know about angles and being congruent, okay? So I know that this angle is going to be congruent to that angle by vertical angles, okay? So we're using the fact that diagonals bisect each other, essentially, to prove that opposite sides are congruent. Okay, which then if I do the vertical angles still, those angles are congruent to those. Okay. Then, now what we can say is, oh, perfect. We have I'm going to highlight this, a side angle side congruent. So because I know that would be the same with side angle side, so those two triangles are there. Because I know I have a side the same, an angle and a side, and that angle's in between the two sides, I know congruent. I know those two triangles have to be congruent. So therefore I can state that opposite side would be congruent, and that would work for those two sides too. Same argument. Okay, so that's one of the ways you could go about it. There's a couple different ways you could prove that. That's the way that we're going to do today. Okay. Are they a parallelogram? That's the question here. Think about the definition of a parallelogram and then ask yourself these questions. Is a rectangle a parallelogram? Is a parallelogram a rectangle? Is a square a parallelogram? And is a parallelogram a square? I would like you to just pause the video and kind of reflect and try and reason and logic out if you can figure these out. Okay, let's look at the answers to this. So the first one, is a rectangle a parallelogram? A rectangle is a parallelogram because the opposite sides are parallel. Is a parallelogram a rectangle? It's not always a rectangle because the opposite sides are parallel. So sometimes let's see. And part of it is why it's not a rectangle. Parallelogram is not always a rectangle. Is that my corners, my diagonals, or my angles in the parallelogram don't have to be 90 degrees. They can be kind of shifted a little bit. Their opposite angles just have to be congruent. Okay, so it doesn't necessarily have to be 90. Is a square a parallelogram? A square is a parallelogram because the opposite sides are parallel and my opposite angles are congruent. And then the same thing for kind of the second question for this fourth one. Is a parallelogram a square? It's not always a square because the angles are not always 90 degrees and the sides are not always the same length. So that kind of bugs that out. Okay, so here's going to be like some stuff that you'll see on the quiz. Solving angles of parallelograms. Parallelograms ABCD is below. The measure of D is 79 degrees. And the measure of C is x plus 3. Solve for x. So one thing that I haven't talked about is that in parallelograms, consecutive angles add to be 180 degrees. Okay? So what that tells me is those two angles right there will add up to 180. So I can say 79 degrees plus x plus 3 degrees equals 180 degrees. So I add my 79 and my 3, and I get, let's see, it's going to be 82 plus x equals 180. Then I'm going to subtract 82 from both sides, and I get x equals 98 degrees. Okay? Simple enough. Okay, now you try solving angles. Okay, so measure of angle A is 107. The measure of angle C is 4x minus 8. Solve for x. So we know that opposite angles are congruent, so I can say 107 equals 4x minus 8. So simply here, I'm going to add 8 to both of these. So that gives me 115. Yep, 115 equals 4x. Then we're going to divide by 4. I don't think 4 goes into 115 at all. So I'd say x equals, let's go up here, 115 divided by 4. We get 2 here, 35, 28 point, we get 28.75. Okay, perfect. Okay, solving sides. So side AB is 31. Find the measure of CD. Well, that's easy. We know those sides are parallel. They're parallel, but they're also the same length. So I know it's 31 centimeters. That's an easy one. Okay, side AB is 11. Side BC is 18. Find the perimeter of the parallelogram. This one's pretty easy too. We know that's 11 and that's 18. So I can say 2 times 11 plus 2 times 18. Perimeter is the distance around, if we remember that, okay? So I get 22 plus 36, which gives me 58. Okay, the other thing that I want to talk about is that if you have your quiz, I think this question comes up, and I don't think we talked about it, so I want to make sure you get it, is it will ask, so like say, it will talk about something being a diagonal. So you'll have like a diagonal, and I think in some of the quiz questions it doesn't even draw this, and it'll say like point E, and there's no point E. They're talking about something in the middle here. So if they say that segment like AC equals 30, and it will say BD equals, we'll say 20. We'll say find the measure of BE. And you'll be like, where the heck's BE? I don't know where it is. That E is going to be that point you make when you make the diagonal. So when I have two diagonals, remember that they're going to bisect each other. So like BD is 20, but because I'm bisecting it, this would be 10, and this would be 10, because it'd be half. Whoa, what am I doing? Half is not spelled that way. It'd be half of this, and then this would be 15 and 15, because it'd be half of this. Wow, my spelling is off today. Okay, half of that. So BE would just be half of whatever I'm diagonaling here. It's like 10. Okay, if you have any questions, please come talk to me. I'd be happy to help you. Hope you have a fantastic day.